what exactly is virtual machine. See, honestly speaking, in this world today, when we are working with cloud computing, virtualization is not something new. We have been very frequently creating virtual machines, and on top of these virtual machines, we have been installing the required softwares, which can be our web-based applications, which can be console-based applications, which can be services. Various types of applications we install, we use them as and when needed, persist data and so on. But actually, how is virtualization created? See, in the past, we talk about, let us say, absolute basic computer, which has all the required hardware. Let it be your processor, memory, storage, network card, mouse, keyboard, CPU, whatever, entire hardware, which is completely managed by an operating system. The operating system can be Linux, the operating system can be Windows, the operating system can be Mac. The operating system is supposed to have a list of drivers. We call them as device drivers. Yeah, the generation today is very lucky. You don't really bother a lot about device drivers. Most of them are like plug and play. You connect a computer with the printer and you start using the printer. Rarely you need to actually install an additional driver. But those days when I started my career, at least sometime in 1992, 95, 93, 94, the operating system was DOS. It was really a challenge to install the device driver and make the device work on the computer. Of course, with the advent of Windows 95, that was in the year 1995, things became little easy. The device drivers became plug and play, and then we were able to simply attach a device and install the driver with few clicks here and there and make it work. And then things only became easy day by day. And today, most of the people don't even know that the operating system layer in background uses a device driver, which is responsible for converting the high level instructions of the operating system into the low level instructions understood by the hardware. And of course, vice versa, reverse also. And on top of the operating system lies our application. These applications are what we have developed. As a .NET developer, you might have built some application. As a Java developer, you might have built some application. Or maybe C and C++ if you are a legacy developer. Or Python application. Some kind of applications which you might have developed on top of an operating system. So how does this whole system work? The application which we developed, let us say I used C programming language. To do something, I will write my code and I will invoke the API of the operating system, application programming interface of the operating system. That means my application makes call to the OS libraries. And these OS libraries facilitate converting our instructions into the hardware understandable format with the help of device drivers. And at the same time, they take our instructions into the processor on the disk, and like this the entire system is working. So the applications which we build are always specific to the operating system, like C and C++ applications specifically, because the C and C++ instructions are tightly coupled in machine code format with the operating system. Java, .NET now, Python, PHP, these are not OS specific instructions. What they do is, on top of operating system, they build one more layer, which they call it as a runtime layer. If it is Windows, this will be Java runtime for Windows. If this operating system is Linux, it will be Java runtime for Linux. If this is Mac, this will be Java runtime for Mac. And this runtime, which is very specific to the operating system, will then be responsible for converting the instructions which we compile, let's say from Java source code to Java bytecode, and the bytecode instructions will be compiled by Java runtime into OS specific, and OS specific instructions will further go down to the hardware and execute. So these languages, Java, now .NET Core, Python, PHP, All this we put it under the category of platform independent programming languages, for the reason that they are not tightly coupled with the operating system. The compiled output of Java, called as bytecode, the compiled output of .NET, we would call it as MSIL code or IL code now. Likewise, we do have PyCode, Python compiled output. All these things require the respective runtime. And the respective runtime, which is tightly coupled with the operating system, will take care of converting from one format to the other format and execute. Blah, 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 blah story. Not really interested in that. Point is, if I use, let's say, .NET for development of my application, I might do development in .NET Core 3.2. So I need .NET Core 3.2 on every machine where I should execute my application. Or if I develop today, let us say in .NET 7, I would need .NET Runtime 7 on every machine where I would like to execute my application. That means our application which we have built is pretty much dependent on the runtime which is required for execution of that application. And that too, the compatible version is needed. Fantastic. Likewise, same is the case with Java. You might use Java JVM, and there are different versions of JVM. Python also has got version 2, version 3. Lot of things which are built on Python 2 are not compatible with Python 3 because that was a revolution which came. Point is simple. Every application has certain dependencies, and those dependencies are needed as it is. Without those dependencies, our applications are not going to work. So how do we handle this situation? What if my machine requires Python 2 also, Python 3 also, .NET Core 3.2 also, .NET Core 6 also, .NET 7 also? I want to run all the applications. There will be definitely chaos. There will be definitely a lot of incompatibilities, which can lead to a situation where some application was working already on this particular machine. I installed another application, and that application needed the latest libraries. So on installation of latest libraries, imagine the old version libraries got upgraded, and the new application now starts working, the old application will stop working. This can be a typical situation where we ended up upgrading our applications new version, but some of the old versions will stop working. Radical problem to see, which a lot of people face in the industry. How can this be resolved? Simple. Let's say take a virtual machine. What is a virtual machine now? I would say a virtual machine is nothing but a software machine, a hardware being treated like a software, and with the software we'll create a virtual machine. So ultimately we will have all the hardware here. Let it be CPU, RAM, processor, all that hardware will be there. On top of that hardware, we are going to implement virtualization. We are going to use something like virtual machine monitor, VMM, which can be Hyper-V, which can be VirtualBox, which can be VMware. There are a lot of virtual machine monitors. So these, in generalized term, I could call it as hypervisor. These hypervisors are what I'm going to use for building these virtual machines. Every virtual machine will reserve some hardware from the host. Host is your base, physical hardware, and then there is a virtual hardware which every virtual machine will have access to. So let us say I have got 64 GB RAM on my physical hardware. I may create one virtual machine with 16 GB. I may create another virtual machine with another 16 GB, and these 16 GBs are reserved for the respective virtual machines. And the applications which are going to be installed in one virtual machine will also see that it has got its own guest operating system. So let us assume that we are working with something like this. We are working with the hardware on top of which some hypervisor is installed, And on top of this hypervisor, direct virtual machines are created. These type of virtual machines are type 1 virtual machines. The alternative solution is we have the hardware managed by some host operating system, which can be Windows server, which can be Linux server, and on top of that host operating system, we will have hypervisor, and that is when we can manage the virtual machine. The difference is here we do not have the host operating system, here we have the host operating system, but in either case we are going to have an hypervisor, type 1 hypervisor, type 2 hypervisor, and on top of these virtual machines are created. Beauty is what? Every virtual machine can have its own applications. Every virtual machine can have its own dependencies. And every virtual machine also will have its own operating system. So here I might have a host operating system, which is, let us say, Windows. And on top of it, I'll create a virtual machine in Linux, or I'll create a virtual machine using Windows. In a Linux based virtual machine, I will install all Linux based applications, and on a Windows based virtual machine, I will install all Windows based applications. That means on one physical hardware, we are able to have different operating system environments. Yes, every virtual machine is isolated from the other virtual machine. Every machine is isolated from the other. There is no overlapping at all. Windows will have its own network and IP address. Linux machine also may be part of the same network, but will have its own IP address. And because the guest operating system is absolutely different, every virtual machine will have its own file system. Suppose this application in this virtual machine uses the file system that belongs to this guest operating system, and the other virtual machine will again have its own guest operating system and its own file system. The files of one VM do not in any way overlap with files of another VM. They are absolutely independent of each other. That's the beauty. So like this, when virtual machines are independent, there is no overlapping. Applications with different versions, different runtimes can independently work within each VM, and there is absolutely no problem. Good. Very similar concept of this is what is virtualization. Here also we are going to have a host operating system. On top of the host operating system, we will create a Docker engine. And on top of Docker engine, we'll have some dependencies. Ignore this for a while. And then we are going to create containers. Like virtual machines are created from VM images. For every virtual machine, we need something called as VM image. Something very similar is what is needed for containers also. For me to create a container, we need a container image. So if I write in simple layman's language, I have a VM image, and from the VM image, I'm going to create a VM instance. Like that, we can say today we have got container image, from which I'm going to create a container instance. Generally, people refer container image as simple image and container instance as simple containers. That's it. That's a short form. Container instance is a container, and the container image is a is referred as image. So we need an image. Now this image I'm saying is very similar to the image of virtual machine. What is that a virtual machine image will have? Every virtual machine image is supposed to have the base operating system, which can be Linux or which can be Unix, which can be Windows or any flavor of Linux. And on top of it, you might probably install certain software. And then you create an image out of it. So when I create a VM instance, all that software which we installed in the image is going to be part of the VM instance. Say for example, I create a base machine with Windows 2022 server, and on top of it, I install SQL Server. and then I create an image out of it. From that image, if I create a virtual machine, I will have SQL Server software ready in that virtual machine. Likewise, here also we are going to have a base image on top of which we are going to install our application, our software, and then create an image out of it, custom image we call it, and then from the custom image we can create container. One image can have multiple container instances if needed. In a layman's language, if I explain, I can have notepad.exe. This notepad.exe, I can create an instance and that becomes a notepad instance. This is one notepad instance. Notepad.exe was launched and that became one notepad instance. I can create one more instance of notepad.exe. This is one more instance. So these are Windows based application for which we are creating multiple instances. Like that, in Docker world, in containerization world, we are going to find an image from which we are going to create multiple container instances. Yes, that is what is the containerization all about. But the question is, when virtualization is already there, what is the benefit which containerization is going to provide? When we create a container, every container is again isolated from another container. Every container is going to have its own file system. The applications running in the container, if they create some files or write something into those files, or if they use certain files, these are isolated from the entire file system which would be created for another container. Absolutely independent. No overlapping at all. So when container file systems are independent, can I have the same benefit what I got with virtual machine? I can have one version of my application, let's say .NET application, which I developed in .NET 3.0 or 3.2. I will put in that container all the runtime files which are required by .NET 3.2 application. And when I have .NET 7 application, the .NET 7 runtime will be separately packaged into a separate image. .NET runtime 3.2 one image, .NET runtime 7.0 another image, no overlapping at all. Respective images would be used for building the respective images with our custom application. If I explain in little more detail, I would take the base image for, let's say, .NET 3.2 and top of it add my custom application. And what I'll get is a new image. This I'm saying is base image of .NET 3.0 custom application. What is custom application? The files related to the application which I have developed, the binaries of my application which I have developed, and that becomes a new custom image which has my application. And from this image I am going to create a container. Like that, there can be a base image of .NET 7.0 plus in it I'll put the application which I have developed in .NET 7.0 and I'm going to create a new custom image. Of course, that will have a different name, and from that I'll create a separate container. Is there any overlapping? No. Treat every container as a process by itself. This container runs absolutely independent of this container. This container will have its own file system which is constructed from this and this. This container will have its own file system which is constructed from here, which is based on this and this, and they are absolutely independent. They don't see internal view of each other. So because of containerization, we are able to run the application with ease, as it has not only the primary application files but also all the dependencies which are required for my application to run. Actually speaking, this base image of .NET 2, how was it built? That base image of .NET 2 probably was built with the base operating system and all the runtime software required for .NET 3.2. Likewise, here also we might have the base operating system and then the runtime software of 7.0. So layer by layer images are actually built. I'll talk a little more about it later, but point to understand is containers are isolated from each other. Containers will have file system as defined by the image from which the container is created. From same image, we can have multiple container instances created. Even then they are isolated from each other. A container will have its own IP address. Every container will form a network with other containers on the same machine. So basically, am I not talking the same language what I would do it for the virtual machine? Absolutely yes. Whatever I'm saying for the virtual machine, same thing I'm putting it for the containers also. Then what is the difference? Huge difference. If you look at the diagram itself, a container does not have an operating system of its own. A container will only have an application and its dependencies, but it doesn't have the OS patch. Now the big question, what could be the question? How will the application run without the operating system? Yes, the containers are built in such a way that for all their operating system requirements, they are going to use the host operating system kernel. The kernel where actual instructions are executed will be sent to the host operating system. That's why I said earlier, you should treat every container just as a separate process. And because they are using the host operating system kernel, can I say they are very lightweight as they don't have to load the operating system and the libraries which are used for running the application, unlike as in VM. VM is heavy. Imagine if I have 16 GB reserved for 2 virtual machines out of 64 GB, 32 is gone. And I'm left with only 32 for the host operating system applications. And I can't use that extra memory, that memory, even if it is unused by the applications which are running in that VM, because that is reserved. VM will block it. Unlike that, the container will give us the facility of using what is needed, and of course also giving us the ability to restrict to a particular limit if in case needed. I would say yes, maximum 16 GB, but container might use only 10 GB. Container might use only 8 GB. The remaining can be used by other containers. Container will not block that amount of memory which I have capped for a particular container. Cap can be provided, but there is no lower limit. So yes, very, very important, containers are lightweight. Containers are as good as virtual machine, but they don't have operating system patch. That's why they save lots and lots of memory. If I have 3 virtual machines, 3 times the same patch would repeat. 3 times the memory is invested for every virtual machine, separate patch. Oh, that's expensive. That wouldn't happen in case of container. The same host operating system kernel will be used, though the files will be different. But this leads to one limitation, and you should clearly remember this. I can have host operating system Windows and create a Linux virtual machine, and this application then can be Linux based. I can have host operating system Linux, create a Windows virtual machine, and then this application can be Windows because it has the corresponding guest operating system taking care of all the low-level instructions. And through hypervisor, they're going to the hardware and executing it. In containerization, it's not like that. If the host is Windows, you can only create containers which were built for Windows from images which were built for Windows. If the host is Linux, you can only create these containers which are Linux based. The images, when they are created, they have to be Windows based or they have to be Linux based. Very clearly I'm repeating, images when they are created, at that point of time we have to be very clear, is the image for Windows or is the image for Linux. A Windows image will not work on Linux, a Linux image will not work on Windows. They are very much native. This is one of the confusion which is probably there for a lot of people, that containers are platform independent. No, containers are always specific to the platform for which they are built. Is definitely not a replacement for virtualization, but very similar to virtualization. Virtual machines are unique, isolated. Containers are unique, isolated. Virtual machines will have their own file system. Containers will have their own file system. The directory structure of one container will not be visible to another container. So is the case with virtual machine. Virtual machines will have unique network identity. Same thing with container. They form network. Applications from one virtual machine can communicate with application in another virtual machine. So is the case with containers. The application in one container can communicate with application in another container. Application to application communication can happen. I can have my web application bundled in one container and my database application bundled in another container. I can do that. And the web application, by way of connection string, which includes the IP address of the other container, can talk to the database container. Though they are very similar, containers do not replace virtual machine. In most of the situation, it may happen today, especially in the world of virtualization. When we move to cloud like Azure or AWS or GCP, we actually create virtual machines, and inside those virtual machines, we'll create containers. The host can be virtual machine, but in addition to that host, there can be containers created. That's the beauty we can actually enjoy today. Yes, containers are the future way of developing and distributing applications, so that the life becomes easy, as we don't have to take care of the dependencies, as they're all bundled together in a common image. So that's why I say container is nothing but virtual machine minus guest operating system.